Alright, in this video we will once again be practicing graphing the tangent function with all of its transformations. So, let's start with what we have here. As far as the a value is 1. Alright, so there's no stretch happening. Now the b value. The b value is really all of this right here in front of the x. Okay, so my b value is 2 pi. That's going to really affect the period. Now, there's nothing being added or subtracted on the inside of the parentheses, so that means there's no phase shift. There's nothing being added or subtracted on the end, so that means there's no vertical translation. There's no k value. Alright, there's no negative in the front or even inside the parentheses, so there's no reflection. Whoops, I forgot my E. None. Alright, and also there's no reflection. I'll come back to the vertical asymptotes as I am doing my graph. It's easier to do that visually. There's something that's not listed that we definitely need, and that is the period. So let's go ahead and write that down. We need the period. Now remember that the period is always the normal period divided by the b value. And for the tangent function, the normal period is pi. So for this special function, this transformation, it's going to be pi divided by the b value. So pi divided by 2 pi. Alright, these pi's are going to cancel out, but that's going to give you 1/2. Alright, because it's sort of like having 1 pi over 2 pi. The pi's cancel out, you have 1/2. So that's the period, is going to be 1/2. Alright, I'm going to come back to that in a second. Now, because there is no phase shift, the tangent function is going to start at 0, right in the middle, as usual. So what I'm going to do is I will go ahead and just label myself a nice 0 right in the middle of this graph. Okay, now I'm going to use every one of these marks. I always let them represent 1/4 of the period. So if I go over 4 places to the right, that should be the end of the period. So if I go over 1, 2, 3, 4, the period should end here. Now, we just saw that the period was 1/2. Remember? So that's why I'm marking this as 1/2. So I'm going to have one period to the right. For tangent, we like to always draw 2 periods. So we draw 1 period to the right, and I like to draw another period to the left. So again, 1, 2, 3, 4 spaces, and this will be -1/2. Right? It's the mirror image of this one. Now, like I said, the tangent function starts off at 0 when there's no phase shift. And it also ends at 0. So the beginning and end of one period of the tangent function is going to be right there. Now, similarly, if I go the mirror image of this, 4 spaces to the left, the tangent function will be at 0 here again. Okay, now let's go ahead and label all of the marks on the x-axis. So if this is 1/2, then right here in the middle should be 1/4, and half of that should be 1/8. All right, and this should be 3 of these, so this will be 3/8. And these will be the mirror image of these. So this will be -1/8 and -1/4 and -3/8. Okay, now right in the middle between right in the middle of each period there should be a vertical asymptote. So halfway between the x-intercepts there will be a vertical asymptote. So there'll be one here and there'll be another one here. Now the tangent function is always increasing. So as I go from left to right, the tangent function should be always rising. So if you start from the x-intercept and keep an eye on that vertical asymptote, the tangent function should curve its way toward the asymptote, something like this. Then it picks up on the other side of the vertical asymptote, and again it's curving its way in towards the x-intercept, something like this. Alright, so this is what one period of the tangent function looks like. Basically, I'm going to do the mirror image over here. So again, tangent is always rising. So as I go from left to right, this should be curving its way towards that vertical asymptote, something like this. And then it picks up on the other side down low, and again, always increasing as it curves in towards that x-intercept. So now I have drawn two periods of my tangent function. So now I just need to put in my y-axis, which always goes at 0, and I'm going to mark it with the a value and draw the stretch points. Alright, let's look back. There's my y-axis, of course. Now let's look back and see that a value. Well, the a value is 1. Which is not the amplitude, because tangent does not have amplitude. It goes up forever and down forever. But that a value still has a roll. Halfway in between the x-intercept and the asymptote, the graph should hit that a value. So that's this point right in the middle, and that point should be at the a value, which is 1. Now if I look to the left-hand side, this is the point that's right in the middle, and that is also using the a value, but it's the negative version, so -1. And the same thing's going to happen over here in the middle. This should be at -1, and at this point in the middle, it should be at +1. So we need to make sure we are marking the a value on the y-axis, and we are including these extra dots on the graph. So that's it for the graph now. What we need to do is list out 3 vertical asymptotes. We have 2 showing. We have one at -1/4 and another one at +1/4. So let's go ahead and write those down. Okay, so we have, we always say x equals for any vertical line. So x equals -1/4 and x equals +1/4. Okay, now look at this 1 as an odd number. And we're going to do odd multiples of this to get more vertical asymptotes. So this is 1/4. So there will be another vertical asymptote at 3/4. Okay, now if I needed more, there would have been another one at 5/4. And there would have been another one at 7/4. And another one at 9/4. Okay, the vertical asymptotes always occur at odd multiples of, well, this is half of the period. Anyway, that's going to do it for problem number 5, which should look just like this. Okay, let's take a look at problem number 6 and do the same thing. Now, my cheating game is extreme right now because you guys have to draw all this on your own. So let me take away some of this cheating. Alright, that's a little better. I trust you can draw a line and put a bunch of evenly spaced marks on it. Alright, make sure you have at least 8 marks minimum. Alright, now let's go back and actually do the problem. Let's see, let's talk about our a value, which is right here. Alright, our a value is 1. That's going to tell us that there's no stretch happening. I see we have a b value here. Okay, a b value of 2. That's going to change the period. We'll talk about that in a moment. I see that we have a k value. Well, first of all, there's no h value. There's nothing being added or subtracted inside the parentheses. That means there is no phase shift. Now, this number being added on the end, that's my k value, and that's going to be a vertical translation. So this is going to be, the whole thing is going to be moved up 1. All right, whatever I do is going to be moved up 1. So watch out for that. There's no negative sign in front or here, so there is no reflection. So I'm going to say none on that. Okay, so we'll be very careful to deal with this vertical translation. But before we do anything else, we also need the period. Okay, we need to figure that out. Now remember that the period is always the normal period divided by the b value. For the tangent function, the normal period is pi. So for this transformation, the period should be pi divided by this b value, which should be pi over 2. Okay, so fine, the period is pi over 2. Now, because there is no phase shift, the tangent function should start right in the middle. There should be a point right at 0 in the middle of this graph that I'm about to draw. So I'm going to go ahead and mark 0, knowing that there's going to be a point there because there's no phase shift. But now let's talk about the period. The period is pi over 2. Now, I always let each one of these marks represent 1/4 of the period. So if I count over 4 of these, that should be 1 full period. So this is 1, 2, 3, 4. Now we just said that the period is pi over 2. So I'm going to go ahead and throw a pi over 2 down. I'm going to draw 2 periods of the tangent function, one going to the right and one going to the left. So I might as well do the mirror images, a mirror image of this. So 1, 2, 3, 4. This should be negative pi over 2. Okay, now I'm going to go ahead and put a few dots on this graph right now. Well, man, you know what? I got to be careful because of that vertical translation. So you know what? I think I will go ahead and put in my y-axis. All right, and I think I will go ahead and put some marks on the y-axis so I can do some shifting here. So I'm going to put a mark here and here and here. Okay, so this is going to be 1 and 2. Okay, now I had a vertical shift of up 1. So that means instead of the x-axis, my midline should be here at 1. So I'm going to draw a dotted line at a height of 1, and that'll be my brand new midline. Okay, so there is my brand new midline. Now, I know that normally the tangent function starts right here at 0, at the midline. Now, the midline is up here, so that's where the tangent function will begin, with the very first dot on the midline. Now, the tangent function begins and ends on the midline. So this is the beginning. The end of the period is here at pi over 2, 4 spaces over. So it's going to once again hit the midline here. And I might as well do the mirror image to the left as well. Now, we've learned that right in the middle, all right, between these 2 points, between the 2 points that are on the midline, normally the x-intercept, but now on the midline, there should be a vertical asymptote right through the middle between these 2 points, and there should be another vertical asymptote right through the middle between these 2 points. Okay, but you know what? Before I draw the asymptotes in, while I have plenty of space, let's go ahead and label all of these marks on the x-axis. So if this is pi over 2, then this should be pi over 4, right? And this should be pi over 8. And this should be 3 of these, so this should be 3 pi over 8. Now on the left, these should be the mirror images of these. So this should be negative pi over 8. and negative pi over 4, and negative 3 pi over 8. All right, now let's go ahead and draw in those vertical asymptotes right in the middle between these. All right, so there are my vertical asymptotes. Now the tangent function is always increasing. So it's going to be doing this sort of wave inside of here, increasing like this, starting low and ending high. So keep that in mind as I include my stretch points. Let's go ahead and view the A value. Let's remind ourselves. The A value is 1. So that is not the amplitude, because tangent goes up forever and down forever. But the A value does serve a purpose. If I look halfway in between the midline point and the vertical asymptote, the function should be at the A value, sort of as though it were the amplitude. So I'm looking at the midline, not the x-axis. So the A value is 1. So right here in the middle, the graph should be 1 above the midline. All right, not at 1, but 1 above the midline. Okay, so it should be here. And on the other side, it should be 1 below the midline. So it should be right here. So remember, picture the tangent function going like this. So you can kind of see it now. The tangent function should be curving its way in. And then it should be curving back out again as it moves towards the vertical asymptote. All right, so that's what the central part of the tangent function should look like. Now, over here on the right, the tangent function will pick up from below and go in this direction. But let's go ahead and include those additional points. Halfway in between, it should be at the A value. It should be that far below the midline. So it should be 1 below the midline. So it should be right here. Okay, and remember, it'll be increasing. So halfway in between, this one should be 1 above the A value. So it should be here at 2. So using these extra points, it helps to guide our picture. You know what? My OCD is bothering me. I wanted these to be blue as well. It's more visible. Okay, so this should be always increasing for the tangent function as it approaches the vertical asymptote. And picking up from down below, this should be increasing, increasing, increasing as it approaches the midline. All right, so that is what 2 periods of the tangent function should look like. The last thing we need to do is list out 3 vertical asymptotes. We have 2 showing, one at negative pi over 4 and one at positive pi over 4. So let's go ahead and write those down. I might as well just use blue. So we always say x equals for a vertical line. So x equals negative pi over 4, that's a vertical asymptote. X equals positive pi over 4. Now there will be more vertical asymptotes at odd multiples of this. This is 1 pi over 4. So think 1, 3, 5, 7, 9. So this is 1 pi over 4, so there will be another one at 3 pi over 4. And if we kept going, there'd be another one at 5 pi over 4, 7 pi over 4, 9 pi over 4. Odd multiples of this, which was half of the period. And that's it for problem number 6. Now this video is getting long. I'm going to stop this video. And I'll do number 7 on its own video.